Good day, everyone. My name is Nayo Boy, a lab assistant at Force Discovery Center, ReVEL facility. ReVEL stands for Remote and Virtual Education Laboratory. ReVEL is operated through an international platform, which is LabsLand. Because of physical distances and lack of resources, especially in historical disadvantaged institutions, to perform experiment and sophisticated research, ReVEL was established at the University of Fort Hare in 2019. This facility is the first of its kind in South Africa, and it enables students and researchers to perform online experiments using remote and virtual laboratories. Remote labs can be used as alternatives to physical hands-on experiments, which is beneficial during the pandemic we are in. The ReVEL team identified syllabus-based experiments for physical sciences and converted those experiments to ultra-concurrent experiments, which can be accessed through LabsLand website, that is our collaborating partners. Through our collaboration with international institutions, to mention just a few, Spain, Brazil, and Colombia, UFH students are also enabled to access and perform experiments recorded by these international institutions. As ReVEL team, we are going to show you two physical science experiments. Welcome to ReVEL Laboratories. This lab has all our ultra-concurrent experiments. Today I will be showing you the syllabus-based experiment called Ohm's Law. This experiment was recorded by the ReVEL team at the University of Fort Hare, and it is for grade 10 learners. This is how you access the experiment. Then you go to observation. This experiment has two parts. Part 1 is to show that what happens to the potential difference and the current when resistors are connected in series. And part 2 is to show that what happens to the potential difference and current when resistors are connected in parallel. Before doing the experiment, let me show you the equipment that is used on this experiment. On this circuit view, we have 4 batteries, each with 1.5 volts. These are our connecting wires, and this is the resistor. Also, this white board is a circuit board. On this screen view, we have 2 multimeters. This big one is for potential difference, and this one is to measure the current. However, these multimeters can measure 3 components, that is current, potential difference, and resistance. But we are only interested on the potential difference and the current. Now let's look at this diagram. It also have 4 batteries, and this one is the symbol for the resistor. This is the button which allows us to change the connection of the resistors. You can see that it has different combination of resistors. If we select this combination, the circuit view changes. Now we have 2 resistors connected in series. Also, on the screen view, there are changes on the potential difference, and also there are changes on the current as well. Now let's look at this combination. You can see that now the circuit view has changed. We have 2 resistors connected in parallel, and on our screen view, the potential difference has changed, and also the current has changed. Now let's start with the first part of the experiment. where we want to see what happens to the potential difference and the current when resistors are connected in series. We will select three resistors. These are our three resistors connected in series. If we add the potential difference of each resistor in this circuit, it will give us the total potential difference of the circuit. And that total potential difference is displayed on this multimeter. Now let's look at the current. The current comes from this positive side of the battery and it only has one path. That means the current that is flowing on this resistor is the same as the current that is flowing on this one and is the same as the current that is flowing on this resistor. Therefore, this current that you see on this multimeter is the total current of the circuit. Hence, we say resistors in series are potential difference dividers while current remains the same. Let's move to the second part of the experiment, where we want to see what happens to the current and potential difference when resistors are connected in parallel. We will select this combination. On our circuit view, we can see that these three resistors are connected in parallel. The theory says when resistors are connected in parallel, the potential difference is the same on each resistor. That means this potential difference that is displayed on this multimeter is the potential difference for each of three resistors. Now, let's look at the current. The total current comes from the positive side of the battery. When it reaches this junction, it splits. Now we will have current I1 passing through this resistor and current I2 going up. When current I2 reaches this junction, it will also split into two. This means we will have three different currents, I1, I2, and I3. I1 will pass on resistor 1, I2 passing on resistor 2, and I3 passing on resistor 3. But when these currents meet at this junction, they will be added up to the total current. That means I total will be equal to I1 plus I2 plus I3. Therefore, this current that is displayed on this multimeter is the total current of the circuit. Hence, we say resistors in parallel are current dividers while potential difference is the same. After the learners have performed the experiment, they will write the activity and conclude on what they have observed on parallel circuits and series circuits. Thank you.